10th May LeetCode question. Minimum equals sum of two arrays after replacing the zeros. So basically we will be given two arrays that might be containing zeros, and the job is to replace these zeros with a positive integer such that we can equalize the sum of these two arrays. For example, the raw sum of this array is 11, the raw sum of this array is 6. We have to replace all zeros. So suppose the job is to minimize, right? So we replace it with the minimum positive integer, that is 1. So the new updated sum is 12. Now we have to accommodate this 12 into these array, right? So we can put here 1 and 5, we can put 2 and 4, we can put 3 3, we can put any combination. We don't care about the combination here. We have to return this value 12, the minimum sum that we can obtain, right? So, and also if it is impossible to get that sum, we have to return -1. Now the only thing to consider here is that when will we not be able to solve this? I mean, when will we not be able to equalize their sum? So if you think, even if there is a single 0 in both arrays, then we can always equalize them, because there is no limit to the value of 0. We can put any value, any positive value in the 0, right? So, but the problem starts to arise when there are no zeros in one of the arrays or maybe both the arrays. So here is an edge case. Suppose there are no zeros in the second array and the sum is 5. There are two zeros in the first array and the raw sum is 4. Now, even if we put 1 over both the zeros here, the value will get 6. So we will never be able to equalize the sum because we cannot increase the sum of this second array, right? So this is the edge case that we have to consider, and the approach we're going to use is pretty simple. We have to find the sum of both the arrays, and we have to count the number of zeros, and then we can consider the edge case with an if condition, and otherwise we're just going to return our answer. So the time complexity is of n, the space complexity is of 1. All right. So S1 stores the sum of first array, S2 is the second array, Z1 is the count of 0 of the first array, Z2 is the count of 0 of the second array. S1 plus equals to I, and Z1 plus equal to, if the value of I is 0, it will increment, otherwise not. So now we write the edge case. If suppose the number of zeros in the second array is 0. So we are considering this example. The number of zeros in the second array is 0. So what should be not there? When will we not be able to equalize? When the sum of first array and the number of zeros in the first array is greater than the sum of the second array. So, and S1 plus Z1 greater than S2. The same goes for other array. So if the number of zeros of the first array is 0 and we have S2 plus Z2 greater than S1, we return -1. Otherwise we return the maximum of S1 Z1 and S2 Z2. Wait a second. I don't know, maybe bracket. Plus Z1, S2 plus Z2. Okay, I'm stupid. I'm sorry, I don't have time to record this again. Sorry, so I'm gonna upload this. Okay, so that's how we can solve this, and let's submit this, and it's working completely fine. Let's see what have these guys done. So approach is pretty simple, right? The conditions are same and everything is same, just they have written these things and I have not. Okay, so logic is same for all this, even though our complexity is not good here, but it's the optimal solution. Okay, I will upload the solution in the link, GitHub link in the description. All right, thank you.